Stream channels. So water is moving into these watersheds. It's carving the landscape. The higher the energy of the stream, the higher the competency and capacity. Energy level is about velocity, and velocity is about the gradient of the watershed or the stream channel. So the higher the velocity, the steeper the gradient, the higher the energy, and the ability for that stream to move different size particles, so higher velocity, higher competency, bigger particle size, and then that also relates to the volume of sediment. So that's the capacity, how much volume of sediment the stream can move. Stream deposits are called alluvium, also called fluvium. We'll call them alluvial sediments. These are the particles carried and deposited by a stream. And they usually have a real distinctive deposition pattern. There will be different grain sizes, clays, silts, sands, gravels, all in that alluvial environment. Depends on like flood deposits are going to be a bigger grain size, but flood plain deposits might just be a muddy grain size. And then there are stream channels that have lots of sandbars in them, and then muddy spots where the velocity is different. So that's one of the characteristics of alluvial sediment, is a lot of different grain sizes in that environment of deposition. All right, so stream channel patterns. This one in the image here is braided stream. So the stream can be one channel, but then it splits up into many different channels separated by these sandy bars. Sometimes vegetation will grow on those sandbars and they will have a little bit of longevity to them. You wouldn't build a house there, right? The next flood comes through and knocks all that vegetation down, and a new stream channel comes right through the middle of that sandbar. So these streams are full of sediment, and that's usually characteristic of a place maybe that there's been disturbance, like a forest fire, but also in areas like adjacent to a glacier, where a glacier is grinding up lots of bedrock and making lots of sediment. So the floodplain can be really wide, the stream channel can be really wide, the water's not very deep, kind of slow, and meanders, doesn't meander, it braids through this channel. Meander is a whole different thing. So this is where a stream, we use it as a verb, meanders through the floodplain, and has many bends in the channel, back and forth. The outside of the bend is called the cut bank. The inside of the bend is the point bar. On the outside, the velocity increases and there's erosion, so it's cutting, cut bank. The inside of the meander, the velocity slows and there's deposition, and that's the point bar. The stream, because it is eroding at the cut bank, is moving in the direction of the cut bank. So in this image here, let's go pick up this pen. The stream is moving in that direction, right? At each of these meander points, it's moving as it erodes at the cut bank. It's moving this way, right? All that's moving that way. Sure. All right. Here is a stream that is straight and through a field. So that might lead us to believe that this is an unnatural stream. So it is. They've cut it straight through this pasture to drain the pasture. So it's an unusual pattern if you see it cut straight through the pasture there. What that means is it's channelized. Sorry. Oh, there we go. Artificially straightened. A normal stream would look more like this, where we have point bars growing on the outside, on the inside of the stream channel, and then erosion at the cut bank on the outside. Deposition on the inside, erosion on the outside. The velocity increases as it goes around this bend. Goes around the bend and erodes that cut bank, depositing material in the slope area of the stream on the inside of the point bar.